you got 361, 296, minus 280 cosine of A. This next step is where some of you will make your mistake. I cannot combine the stuff on the right-hand side. Since that 280 is being multiplied by something that you don't know, you cannot combine them. And you're just going, whoop. That's why you were getting domain errors. That's why it wasn't working. Remember, this is an unknown. This is something times an unknown. You cannot, if this was 3 minus 2x, I could not write that as x, could I? Same rules, just different letters. So you work backwards, subtract the 296. I think this was 65, if I'm not mistaken. Don't forget to bring out the negative. That's also a simple mistake. It'll still work if you don't bring down the negative, but your answers will all be wrong. So divide this out by the negative 280. 65 over negative 280. That crummy decimal is the cosine of A. Now you inverse it. Okay? Now you're inversing something within between 0 or between negative 1 and positive 1. You were trying to do it over 1, wasn't it? It said domain error, didn't it? That's fine. Thank you. So there's your angle. Your angle will be at 103.42 for that first angle. Now, as you go back to you just find the next largest angle. The next largest angle has to be angle C. So you would circle your A in the side opposite like you would before with the law of sines. And we just write it out this way. Sine of 103.42 is to 19. Sine of C is to 14. We know that right away we'd have to multiply by the 14, so a lot of times people just write 14 here. You don't have to rewrite it. Type in all that stuff with the fraction bar. Then now make sure you hit inverse sine because you're using a lot of sines. Calculator. Fraction bar 14 sine 103.42 over 19. Inverse sine of the fraction. 4578 for C. And now you have two of the three angles of a triangle. Just subtract it out and get the third. Was it like 32 and change? 31 and change, something like that? Am I close? What is it? 3102? Sounds. I know we did this one earlier, so I'm just guessing. Can we get 3102-ish? One of the questions I was getting in the second hour with these is when people were writing the things out before they were using like the answer button, they're rounding things before they're using the answer button. Don't round if you can use the answer button. What you're doing is you're making your answer veer more and more off from being close as you would more accurate. It's less accurate the sooner you round. So try not to round until you're very, very, very end. Okay. That's the goofiest of the style I always felt when you had to find the angle, because you have to do a little bit extra work. Right? If you don't have to find the angle, it's literally typing the whole thing in and then taking the square root. That gives you the side point. So that should be the easier of the two. What's up, guys? What'd you mess up, Harlan? Oh, he's missing a digit or something? Oh, gotcha. Yeah. It's like I said, the mathing of it isn't tough. It's just a lot of buttons. Okay? It's just a lot of buttons. So, like I was saying with the natural progression of all this stuff, like we did with the Sophie-Toa things and the elevations, we started doing a little bit of the word problems. We kind of did the same thing with law signs and with law cosines. So what I wanted to do today is kind of go through a few of those ideas with you guys, to show you how these things work, how do you draw pictures with this information, and how do you make a decision of which one you're going to use. Go. As you get this one, please cross off number 4 and number 6. No, I'm sorry, not number. Yeah, number 4 and 6. Those two are a little bit more complicated for a regular old geometry class. We need to worry about those as that fancy ones. The rest of them are relatively straightforward. And I'm going to walk you through how you set up a few of them. That way you see which ones we use when. Okay? So, let's look at number 1. Number 1 says you've got a couple of ice skaters, or figure skating routine. Jackie and Peter skate apart at an angle of 15 degrees between them. Jackie's now 5 meters away, and Peter skates for 7 meters. How far apart are said skaters? So, we need pictures of skaters. They're starting together, because figure skating, they pull each other and they twirl. See, they twirl.
That was a flip.
They twirl. Okay, better? Okay. I'm sorry, I'm the idiot. Babe, why are you laughing at me? You shouldn't laugh at things like that. They say they skate apart from one another. One person goes one way, the other person goes the other way. They had to start somewhere, right? One person went one direction, the other person went some other direction. What was the angle between them? Where does the angle go? Okay. Now we just have to figure out who's who. He fell on his head, it's a good thing he's wearing a helmet. So, one person went one direction, the other person went the other direction. One person went one way, the other person went the other. All this fancy technology we have here, isn't it? How far does it matter who's who? It really doesn't. But if we say one person went 5 meters, the other one went 7, right? So does it matter where I put 5 and 7? No. We'll say they went 5, they went 7. I don't know who's Jackie, who's Peter. Or is it? Jackie. Well, whatever. It was Peter the set. All right, so Peter's the guy whose skateboard. Jackie is twirling away. What we need to figure out then is how far apart they are. So I'll have to move them. Because I clicked it to spin forever. All right. Anyway, so she's kind of out of the way now.
She's gone.
We need to figure out this distance here. With the given information, is it side, 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 angle, or side, side, angle? It is side angle side, which means what do you have to use?
Law of cosine.
Law of cosines. Good. Now, in this problem, I didn't label anything. Did I need to label anything?
No.
I didn't. Well, if I did, would it make any difference how I label it? No. So, if you want to label it, if I want to use A, B, or C, A, B's, and C's, what one should I put here?
B.
If I put B there, what has to be over here? Little b. And then are these other two just arbitrary? Because does it matter which angle is which? It doesn't, because this still has to be little a, and this would be little c, or vice versa. Because no matter what, when you're adding things, the order doesn't matter. When you multiply things, the order doesn't matter. So if we chose that angle to be angle B, then the side opposite is little b, I'm going to use law of cosines in terms of b. Okay. What's that? Yeah, I started writing it down. Now I just fill in the blanks. What I'm getting at here, even though you don't have any information given to you, you're not labeled or anything like that, as long as you're consistent with what you're looking for, it doesn't matter which one you choose. It's always going to work. If I called that A and little a, it would have still been the same. So I fill in the blanks. Our little b value squared is going to be 5 squared plus 7 squared minus 2 times 5 times 7 cosine 15. Okay. You have all of the information on the right-hand side. It means all you have to do is type it all in. Okay? 5 squared plus 7 squared minus 2 times 5 times 7 cosine 15. I get some crummy decimal. That crummy decimal equaled b squared. So what do I have to do with it? Square root it.
Oh, that's why.
Okay, remember, that all equals b squared. Now that side across is 2.53. Okay. Did it ask to find anything else?
No, but it wouldn't be.
Yeah, that's fine. I'm not going to yell if you don't label. Like I said, really the only time I worry about labeling is surface area volumes. Okay. That's not too bad, was it? Huh. All right, second one. Second one says a triangle is supported by, a bridge is supported by a triangular brace. If the sides of the brace have lengths of 63, 46, and 40, find the measure of the angle opposite the 46. Bless you. So, a bridge, do I have to draw the bridge? No. It just says I have to look up the triangle brace. So all I have to do is draw a triangle. What are the side lengths they give me? Does it matter where they go? No. 63, 46, and 40. Does it matter what I label them?
So we don't have to be like sine, over.
For which one?
The first one.
What did it just ask for? And that's the trick with with the word problem ones. It's the main part is setting it up. Usually you're just solving for one. Sometimes you might solve for two parts of it, but there's usually not as much work. So if I call this just A, B, and C, it's asking us to find what? Now is the angle opposite 46, is that the biggest angle?
No.
No. So can I find that right away?
Not yet.
Not yet, right. So if this is the case, it forces you, even though you know you want to use law of cosines to find it right away, you can't. Because in order to use law of cosines when you have three sides, you always have to find the biggest angle first. That's always the rule. Okay? So you'd use law of cosines to figure out angle C first. Then you would use law of sines to find A. Okay? That's the trick on that. Obviously, you could label it however you want, but if I'm calling this A, B, and C, this is my little c, little a, little b. Okay? Now this problem turns itself into something you did yesterday, except for that one last step of finding the third angle. You just got to find the second angle. Yes, ma'am? What happens with that? Anyway, don't you know? happens
I was
is,
saving this.
I was trying to back you up. Alright, so we would just use that, okay? How many feet are in a mile?
500. 5,226.
5,280. Remember,
I was
it's
close.
one of the things you need to know. So in number 3, it talks about 1/2 a mile. What I want you to do is cross that off and figure out if a mile is 5,280, what's half of that? Change that to 2,640 feet instead, please. Okay? Now, when you go to think about what this is, this problem says you've got two observers across from one another, 2,640 feet apart. Wouldn't that just be a straight line? I think they called them A and B, didn't they?
Yeah.
And that gives you two angles to point C, doesn't it? Angle A and angle B. Where do you need to put angle C? Can it be at the top? Can it be at the bottom? Does it matter? If I put it here, does it matter?
Doesn't matter.
Fill in the rest. Do you know what it means to be due south? What's that? Straight south, yeah. So when you draw a compass on a piece of paper, what goes at the top? North. So if I'm looking at 5, it says on a map, Orlando is due south of Niagara Falls. What's on top, Niagara or Orlando? What's below it? Orlando. So I would say Niagara Falls and then Orlando. They're this far apart from it. Does it tell you how far it is distance-wise? Number 5. It does, doesn't it? Then it talks about another place called Denver. I don't know if you've heard of it. Never. Gives you distances here and here. I think you finished that out. Like I said, number 6, I would want you to skip. Number 7 is almost identical to number 4. Yeah, I said skip. Yeah, 6 and 4, I said that, yeah. So like I said, 7 is very much the same thing as number, did I say 4? I meant 3. My apologies. 7 is pretty much the exact same thing as 3. I'll let you guys finish that one through. So I want you guys to finish those, and then I have one other quick little set. This goes back to what we've done the past 2 days with just the straight triangles, solving all the parts. What I did was I put one of each possible style for sine, one each possible style of cosine, which means there's 4 possible ways these things can look. You have to figure out which thing you're going to use to set them up and solve, okay? Now, tomorrow, when we do our quiz thing on this, I will collect both the word problem and this sheet you guys are getting. Okay, I'll collect both of them tomorrow. The quiz itself, I don't think it shouldn't be that long. I will give you the law of sines, law of cosines. I won't tell you when to use them. That's up to you guys to figure that stuff out. Okay? And then you have to remember how to press the buttons to practice. The more, I keep saying this over and over and over again, when it comes down to these types of problems, always write down what you're about to type in before you do it, so that way I can figure out where you screwed up. My honors class, like I said, just the other day, took a big quiz on a lot of this stuff, and even they were screwing up with buttons. It's very easy for me to figure it out, but I need to know what you're doing, okay? Please start working. If you have questions, raise your hand. You guys got a little extra time, so you guys can go ahead. Yes? Yes, ma'am. Both of them. Yeah, 2640, 2,640. It's easier to do it that than a fraction. How'd you figure that out? You're like all of a sudden I was angry about it. Why did it just do this? We can make it more difficult. Is that this between those 2 points then, point A and point B?